Hello everyone, my name is Yamini Shale and I am a subject matter expert at Fice Education Private Limited. And today I welcome you all for our webinar session on integration of mobile app with Intel Galileo Gen 2 development board. Before going in depth of this particular webinar session, let us have a look at topics which we are going to cover in this webinar session. Firstly, we are going to cover the applications of mobile app in embedded and IoT domain, and then some wearable computing devices and its relation with mobile app, and then present technologies which are supporting communication between mobile app and microcontroller, and then we are going to discuss that how we can integrate a mobile app with Intel Galileo and what all applications I can create if I interface a mobile app with an Intel Galileo. Considering an applications of mobile app in embedded and IoT space, the first and foremost things that comes into picture is a consumer electronics. In consumer electronics, if I consider home automation, in this home automation, an internet connected home devices will be able to coordinate energy usage, consumer convenience, and possibly accurately and consistently anticipate the needs of the people who lives in the home. And in home automation, each IoT enabled device in the home is connected to the home network and accessible directly over the home network and even remotely from across the world. If I take an example of smart keyless lock, which is an device connected to the home network and which allows the homeowners to grant access remotely. This smart keyless lock views images from the door lock's point of view, and this lock system even schedule access for various users for various times, and the permission can be granted and revoked as simply as accessing a web page or app setting on a smart device. If I consider in a lighting system, a Wi-Fi enabled lights allows the user to access them remotely, and these wireless lights not only allows the residents to turn on or off of the lights from across the house, but it also allows them to integrate the lights to control the color of the lights and amount of the lights around the home. If I consider one example, the set of lights can be set to bright and white in a workroom, and same set of lights can be set for a deep blue color around the pool. If I consider HVAC system, an Wi-Fi enabled HVAC system will share the status, the history and the predictive future of the components with the manufacturers to anticipate needed maintenance in advance of the system breaking down. An internet-enabled HVAC will coordinate power usage with the water heater, the furnace, the refrigerator, the freezer and other items that draw the substantial power. If I consider IoT applications in automobiles, nowadays we all know that the growth of connected cars is one of the key technology influencing the automobile industry. And the connected vehicles has been the most visible and familiar example of Internet of Things technology. The automobile industry is launching vehicles that can be driven through roads with little or no hassle at all. It may be to know the shortest route possible, or it may be to customize the vehicle to meet drivers' needs and preferences, or it may be to get the notifications about traffic, or it may be to protect the cars against the theft, or it may be to get the information about the weather and en route destinations, or keeping a tab on drivers' health and behavior. So these all things can be achieved only when a car is connected with the combination of GPS tracking and internet connection. If I consider mobile app applications in healthcare industry, in today's life, attractive advantages of wireless technology accelerated the rapid development of mobile applications. So with the increase of the mobile devices in the recent years, new solutions come to mind including mobile technologies to fulfill requirements or suggest better solutions in the vast area of medical informatics to existing ones. And in the healthcare industry, mobile applications provide better personalized healthcare, disease management, and services to patients and their relatives, as well as a better and flexible way of communicating with physicians, patients, and medical suppliers. It is obvious that the applications using mobile technologies has the potential to bring better conditions both for the patients and for their disease management and for checking their self wellness. If I consider some mobile applications with respect to Intel Galileo in healthcare, I can have an example of Mimo baby monitoring system. So this is a system is a smart sleepwear for baby monitoring. In this, Intel Edison platform is used to connect this wearable device to Android or iPhone, and it can capture information about baby movement, temperature and breathing or respiratory patterns, and that can be relayed to a smartphone or an app for parental peace of mind. If I consider a mobile app application with respect to Intel Galileo in automobiles, a smart helmet will comes into picture. The primary function of the smart helmet is to detect a crash and communicate to emergency contacts. In this smart helmet system, Intel Edison is used with smartphone to detect a crash by using accelerometers and to communicate with emergency contacts. So in this application, the role of a smartphone is used to record ride, distance, speed and path. If I consider a mobile app application with respect to Intel Galileo in robotics, that is a Bluetooth controlled robot. So this robot can be controlled or tracked by using Intel Galileo with an Android smartphone via Bluetooth. Apart from this, the robot records environmental parameters like temperature and light intensity by using the temperature sensor and light sensors. And these values which we are getting from the temperature sensor and light sensor are then displayed on the smartphones. So these are the some real-time examples where Intel Galileo or Intel Edison are used with the mobile apps. So coming to wearable technology, wearable technology is a category of technology where devices that can be owned by a consumer and often include tracking information related to health and fitness. So with this wearable technology, learning more about yourself has not only become high-tech but also it's real-time. From devices and apps that help you to track heart rate and food consumption details to gadgets that monitor your mood and even surrounding air. If I consider one example application, that is a senior tracking device, so it may be in the form of pendant or it may be in the form of band, which can be owned by the elder persons. And this senior tracking device is used to track the activity levels of an elder person, and also it is used to provide the real-time location information of that particular elder person. So like this, Fitbit bands, a Mimo baby monitoring system, all are examples of this wearable technology. So in this webinar session, whatever we have discussed regarding mobile app integration with wearable technology, there is a mobile app always present. So what will be the role of this mobile app in wearable technology is that used to monitor and manage data from the wearables by using wireless connectivity solutions like Bluetooth and Wi-Fi. Coming to present technologies which are supporting a mobile app communication with microcontrollers is a Bluetooth. Bluetooth is a wireless technology standard for exchanging data over short distances from fixed and mobile devices. The maximum range of this Bluetooth device is 100 meters. This Bluetooth module delivers the received data and receives the data which has to be delivered to and from a host system through a host controller unit, that is UART interface. And Bluetooth can be used in applications like hands-free headsets, key dongles and fitness trackers. One more technology is NFC, Near Field Communication Protocol, is a set of communication protocols that enables two electronic devices, in that always one will be a portable device like smartphone, to establish communication by bringing them within about 4 cm of each other. The NFC can be used in applications like smart wallets or smart cards, action tags and access control. Coming to GPRS, GPRS is a General Packet Radio Service. GPRS is a core network, allows 2G, 3G and WCDMA mobile networks to transmit IP packets to external networks such as the internet. And these GPRS can be used in applications like cell phones, mobile to mobile communications, smart meters and in asset tracking. So these are the some technologies which are supporting the communication between mobile app and with the microcontroller. So let us have a look at an interfacing of any mobile app with the Intel Galileo. So before going to that, let's have some features that what Intel Galileo is having, as we already discussed these things in our previous webinar. I just want to have a look at some features of Intel Galileo. That is, first one, it has a support for 48 GPIOs which are fully native for greater speed and improved drive strength. And also it has a support for 8-bit pulse width modulation for more precise control of servos and smoother response. And also it has a support for 6 analog input channels to support analog sensors. And also it has a support for an USB client port which can be used to transmit the data serially. So now I will take one mobile app example how I can interface that with an Intel Galileo, and we will see how I can control all these features of Intel Galileo by using that particular mobile app. The mobile app what we are using is, that is Droid. Droid is a mobile app which is used to control Galileo pins by using Bluetooth wireless technology with host controller UART interface. And Droid is used to control a relay to turn electric gadgets on and off, and it is used to control a robot servo, and it is used to increase or decrease the speed of a motor and in the reverse direction, and it is used to dim the light, and it is used to speed up a fan, and it is used to read the Galileo pins and sensors and then transmit the data which has been collected from the pins and sensors back to the Android phone. So these are the applications I can create when I interface such kind of mobile apps with Intel Galileo wirelessly. Let's have an in detail description of this particular app with Intel Galileo, that how I can control each and every feature of Intel Galileo when I use this mobile app with Intel Galileo. Firstly, how I can control the digital pins. As you can see in the picture here, I have some set of digital pins that are from pin number 2 to pin number 3. As we know that pin number 0 and 1 are dedicated for the UART communication protocol, as we discussed this in our previous webinars. Let's have a look at that how I can control digital pins. If, for example, if I have any one output module which I am connected to any one of the pin, just by clicking on that particular pin, I can control the on and off of an digital pins. If I connect any output devices to any one of the PWM pin to achieve the PWM applications like controlling the speed of a fan or controlling the speed of a motor or controlling the intensity of the light just by moving the cursor with respect to the pin. I can control the duty cycle of that particular pin. Coming to that, how I can send data serially, as you can see in the picture here, there is an option called as send data, where I can send the data by clicking on this particular app to the Galileo serially, where I'll be getting the output onto the serial monitor. If I connect any analog sensor to have an interaction with any physical parameter, by clicking the get data onto an mobile app, I can get the values which we are reading from that particular analog pin. So like this, I can have all the 4 features of Intel Galileo which can be controlled by using this mobile app. For any community support, you can have a look at all these links for the reference also. You can even contact us, that is Foundation for Innovation and Collaborative Education, on the IDs like info@fice.in, that is info@fice.in, and mentor@fice.in, that is mentor@fice.in. And also you can visit our website at www.fice.in. Thank you for attending the webinar.